Hi guys, welcome back to my channel and let's continue talking about petroleum processes. I'm very excited to start this video since I have a lot of new things to teach you guys, and of course this information was new for me, and right now I'm just excited to share it. Yeah, I always try to remind myself that I really like I really keen on my specialty. I'm just day by day I'm starting to love it. The chemical engineering, petroleum process are quite interesting, quite enjoyable thing for me. Uh, so I have a plans to cover this kind of topics, vacuum distillation, solvent refining and its types, conversion, breaking, cooking. Cooking is not correct. I will not cover cooking. We will stop on rice. So vacuum distillation. Let's talk about vacuum distillation. Vacuum distillation, the residue from an atmospheric distillation tower can be sent to vacuum distillation tower. You said that. I hope. I think I forget to mention it last time. I said that vertically it causes uh, uh, so atmospheric distillation towers vertically meters, and here we will have some bubble trays uh, from 20 to 40, depends on the situation. Uh, so in the vacuum distillation tower, we will produce some water, uh, which not produce, we will recover additional liquid at 4.8 to 10.3 kilopascal. Uh, so here we have some uh, changes or difference, I would say. I said that in the distillation towers we use these bubble cap trays, but in the vacuum distillation tower we use random packing and the demister pads. They will be they it looks like that. See that is kind of it's like that. I don't know. When I was a kid, I used to draw like that. It was kind of interesting for me when I'm bored at class. So it's how it looks like in the real tower, which is like tower is like that. Quite beautiful. The overheat steam light vacuum gas oil can be used as a loop base stock, heavy fuel oil, or as feed to conversion unit. Heavy vacuum gas oil pulled from a cycle. The vacuum residue can be used to make asphalt, or it can be sent to a coker or visbreaker unit for further processing. So let's go to the solvent refining. Solvent refining, we said that in distillation tower, we split the mixture into in distillation uh, tower, we will split the mixture according to their boiling points. But in the solvent refining, we will separate or segregate compounds with similar compound types, such as paraffins aromatics are similar to each other because they are similar compound types. So that's why paraffins aromatic go together. The three main types of solvent refining are solvent deasphalting, solvent extraction, and solvent. So solvent dewaxing consists of three main parts: solvent deasphalting, solvent extraction, and solvent dewaxing. Here we can see that the solvent dewaxing deasphalting unit. So uh, first of all, we will take our this tower. First of all, here we will be have as a feedstock for solvent deasphalting is usually heavy or residual oil fraction that comes from the bottom of the crude oil distillation column. This feedstock contains high concentration of asphaltenes, which are undesirable in downstream processes. After the uh, So let's see that this is our um, raw material or feedstock enters. After that, we need to choose one uh, solvent. Solvent. Solvent, mostly propane or butane. A light hydrocarbon solvent, often propane or butane, is mixed with the feedstock. Will enter, and it will mix with feedstock. The solvent, uh, the solvent is chosen for its ability to dissolve the lighter components on the feedstock, leaving behind the acid. After uh, after mixing, the two of them mixed, it become red. They will go to the first to heater. In heater, we will heat our and is subjected to high pressure in an extraction vessel. The solvent's properties enable to dissolve the light components overall, leaving a smooth as fraction dissolve. So by choosing correct solvent in heater, we will heat and we will extract it. So at the bottom will be asphaltenes, and at the top as a light product will be uh, valuable products. I'm sorry for that. So by choosing suitable solvent, we will, in heater, by heating at elevated pressure, we will separate the asphaltene from the uh, feedstock. Uh, so after separating, it goes to the no, there is not separation. They will just, I don't know, they will separate it. No, they don't separate it. They just, in simple words, they just understand that they don't need each other, so uh, I don't know how to express it, so let's go. After that, they go to the separation unit. After extraction, the mixture is about to settle or is sent to a separation unit. In this phase, the asphaltenes and other heavy components separate from the solvent, forming a dense asphaltene-rich phase. So, in simple words, here we now in separation unit, we will have final products such as solvent, asphalt, and other heavy components. Okay, solvent is deasphalting. Solvent deasphalting has several advantages, including it improves the quality of crude oil and makes it suitable for further final processing at the cracking or catalytic unit. It produces deasphalted oil, DAO product, which has a higher API gravity and easy to process. It allows for the recovery of oil components from heavy feedstock. However, solvent deasphalting also has some limitations, such as need for solvent handling and the potential issues with solvent load. It is an essential process in the petroleum refining industry for maximizing the yield of variable products from heavy feedstocks and reducing the environmental impact of asphalting. Another important point that I'd like to draw your attention to here. Here we have, I said that we use protan, propane, and butane, and the pentane. The ROSE process can employ three different solvents, the choice of which depends upon process object. So the main essential thing to remember for all of us is that in this type of process, it's essential, it's vital, it's crucial to choose selective solvent. So first solvent, propane, why use it? If you need to do preparation of food-based stocks, you need to take propane as a solvent. But in the second case, maybe in the next day, if you have to make the asphalt production, you can use butane as a solvent. So after, for example, after half an hour, you have another duty, which is to maximum recovery of liquid. In this case, you can use pentane. Let's go to next, which is solvent extraction here. Solvent extraction. So asks solvent extraction. Solvent extraction used to uh, widely employed process in the production of lubricating base stock and greases. In this context, it's often used to remove undesirable components like aromatics and other impurities from the feedstock to create high-quality base oils and grease. The process is designed to enhance the performance and stability of lubricant. So let's go. Feedstock preparation. Yeah, also uh, the same process. Uh, okay, first of all, the feedstock is dried in contact with the solvent in a counter-current or rotating extraction unit. The solvent is separated from the product stream by heating, evaporation, or fractionation. The remaining trace solvent are removed from the reference. Steam stripping or flushing. Electrostatic precipitators may be used to enhance separation of inorganic compounds. Solvent is then regenerated and recycled. Today, phenol, uh, phenol, furfural, and crylic acid are widely used as solvents. In the past, some refineries saw the Edelano process, in which the solvent is liquid sulfur dioxide, has the hazards of potentially made it undesirable. Fluorinated ethers and nitrobenzenes are happy. So let's go to another case, which is solvent dewaxing. So dewaxing is used to remove the waxes from the lubricating oil. So uh, solvent dewaxing, also known as wax drilling, is a refining process used in the petroleum industry to remove wax and other high molecular weight compounds from lubricating, particularly those used in cold environments. The process is designed to improve the low temperature properties of the lubricating oil, such as ability to flow at cold temperature without solidifying or becoming too viscous. So let's go. First of all, the feed will be entered. The feed is a lubricating oil that contains nuts, and also we add solvent. So the feed and the solvent will be mixed, and after mixing it, they will go to the cooler process. In cooler processes, uh, the uh, amount of sample. Here we have some solvent and the lubricating oils that contain wax is uh, mixed, and they become one property, one type of compound. They go to the cooler. In cooler, we cool it at temperature, low temperature, and of course by it in cold temperature, the uh, fluid will be crystallized. After crystallizing it, they will go to the filtration or separation. The cold mixture is then passed through a filtration or separation system that separates the waxy crystals from the uh, oil solvent mixtures. This process, sometimes called wax precipitation, you will have removed the not remove the separate the components. After that, they will go to the washing. In washing, we just in case of emergency, but we need to make sure that the in our fluid we don't contain any crystals. If we have some crystals, we will wash it clean, and the final product ready. So and I hope they're clear now. Solvent refining process. In conclusion, solvent refining units is separated the substances by their similarity in compound type. Conversion process. Conversion process here says hydrogen to carbon ratio is vital. The methane is the lightest hydrocarbon. About Thomas Edison contribution to oil refining, or how its lamp started to produce more how it's affected to the oil industry, and sometimes um, phase breaking process. He say phase breaking process is a mild form of thermal cracking that achieves about 50% of conversion of natural gas oils and naphtha. It says that the 15% of conversion processes it will convert atmospheric residue to gas oils or naphtha. At the same time, I love viscosity result of fuel produced. Ice breaking comes into two ways forward, short contact and soaking. In short contact ice breaking, the feed is heated about 480 Celsius degree and sent to a soaking zone reactor at 1067 to 2170 kilopascal. The elevated pressure allows cracking to occur while restricting core formation. So it says that this pressure gives us to crack our uh, fluid, but at the same time, this pressure uh, will restrict cork formation. That's a good thing. To avoid overcracking, the residence time in the soaking zone is short, several minutes compared to several hours of light events. Hot wells quench with cold gas cracking process to vacuum to avoid expiration. He says that so we said the high temperature, high pressure allows to crack while restricting cork formation, but the residence time in a soaking zone is short because if we keep it more than uh, this amount of time, it will crack more. So it will affect on a property of the final product in a negative way. So we will um, uh, only keep it in a soaking zone on several minutes. But in a delight cooker, we will keep it in several hours. And this hot oil is quenched with cold gas to inhibit further cracking and sent to a vacuum tube for further separation. Soak fast breaking keeps the hot oil at elevated temperature for a longer time to increase the yield of the middle distillate. In a soaker zone, the fast breaking keeps this hot oil at elevated temperature for a longer time. By this period of time, we will by keeping the longer time, we will increase the yield of the middle distillates. The low viscosity fast breaker gas oil can be sent to an food cracking unit, food ice catalytic cracking unit, or hydrocracker for further processing. As a so guys, thank you for your attention. That's all today. See you on the next videos. I hope it was crystal